I want to welcome all of you to the Bird Polar and Climate Research Center. I do want to just touch on a lot of the challenges we face going forward. And we're very fortunate to have so many young people on campus who are working on these issues because I do believe that's our future. I want to tell you a little bit about the center. We started out in 1960 as the Institute of Polar Studies, and Richard P. Goldthwait was the founder of this center. Since then, I think what distinguishes the center is the scholarship. We have had multiple prestigious journal publications over the years, and I'm just going to run through some of these, and you can see that they range initially mainly in the polar regions, and through time they have gone global, and because climate, as Jan was saying, affects everyone on this planet, and we have to work together to find solutions. We have people here working in geology, or we have people working on remote sensing, people working on ice dynamics. We have people like myself working on ice cores, people working on ocean cores to look at paleoclimatology, meteorology. We have climate modeling. All of these are very important in understanding a very complex system. Now, one of the major findings from the ice core research has been looking at the history of greenhouse gases, and they're trapped in these bubbles in the ice. And we can look at the long-term relationships between temperature, shown here in the red curve at the bottom, and the variations in carbon dioxide. During glacial times, when Columbus was under an ice sheet, we were at 180 parts per million. During interglacials, we run about 250 parts per million. But what we're concerned about is where we're headed. Today, we're at 410. There's no analog in the last 800,000 years. In fact, geology would say we have no analog in the last 3 million years. But the real issue is where we're headed on the present trajectory. In less than 80 years, we're at the top of this curve where we're headed. And the problem with carbon dioxide is it stays in the atmosphere for decades to millennia, impacting the climate of this planet. I think it's also highly relevant that 18 of the 19 warmest years on record are the most recent years. And we actually have to go back almost a century to find the 20 coldest years in our recorded history. The impacts are global. In Greenland, melting that's taking place around the margin of this ice cap, particularly. And people like Ian Howlett and his group are working on this, melting, water streams going through, water going down moulins, taking heat into the ice sheet, lubricating the bottom of the glacier, accelerating its rate of flow. More recently, we've seen changes taking place in Antarctica. The arguments have been made in the science journals that the current rate of retreat is now irreversible for this very large ice sheet. One of the interesting things here, this is an article from Nature in 2018, the scientists who predicted ice sheet collapse 50 years ago. And that was our own John Mercer, and he wrote the first paper on the relationship between CO2 and the loss of West Antarctic ice back in 1968. So we've come a long ways from there. If you go around the mountains of the world, we're losing ice throughout the Andes. This is the Quelccaya ice cap, the largest outlet glacier, 1978. This will morph into 2018. This is what it looks like today. We have lakes forming at very high elevation. These are new geohazards for people who live below. This is the only ice field between the Himalayas and the Andes of Peru. This is what it looked like in 2010, and I'm going to bring you up to 2018 because the thing that surprised glaciologists is how fast ice reacts to climate change. So here we are at 2010. This will go forward every 2 years, and you can see the holes starting to develop in the glacier. And you can see how it's thinning, coming forward in time. By 2016, it's separated in 2 separate glaciers. And by 2018, you can see that there's hardly any accumulation on this ice field. Within the next few years, this glacier is going to disappear. Similar story in the Himalayas. And this becomes very important for people because there are billions of people who live downstream from these glaciers whose rivers and water sources source high in the Himalayas. And there we have a very similar development. We have high altitude lakes, new geohazards for the people downstream, and very important impacts on water resources. So today we'll have Brian Mark talking about the physical science basis. We know that as these glaciers melt, sea level is rising. This is a history of sea level rise. It's rising because the oceans are warming. But if you go back to 1870 to 1924, the rise is being forced mainly by melting mountain glaciers. You get into the mid-20th century, it's being forced by Greenland and mountain glaciers. And at the beginning of the 21st century, we have Antarctica coming into play. Sea level is now rising at 3.3 millimeters per year. More than half of the world's largest cities are on coastlines, and therefore this has potentially major impacts, and we see those impacts occurring now. Here's, for an example, Miami, Florida, during high tide, and this is more and more frequent in that part of the world. We have biological impacts, coral bleaching, and we have acidification of global oceans. And Andre Guttoli is going to be telling us about those impacts. Tropical diseases are on the move. They're moving to higher latitudes, higher altitudes, and we're very fortunate to be able to have Qinghua Sun, who'll be talking about public health impacts. Agriculture changes. All you have to do is watch the news and see the destruction along the Missouri and the Mississippi River due to flooding. But here in Ohio, we have warmer temperatures in the winter and at night. We have more rainfall. We have more intense rainfall. Fewer work days for our farmers in the fields. And then there are other impacts. There are things like soil erosion, nutrient runoff. We're very fortunate to have Margaret Kelly, who will be talking about this as we go forward in time. I think this is a very interesting diagram. It shows increasing impacts on the left, likelihood. And when you look at this diagram, and you look up in this quadrant, you can see that the things that are most likely to have large-scale impacts are things like water crisis, failure of climate change, mitigation, adaptation policies, and top of this list is extreme weather events. Economic impacts. This is from Barron's in January 2019. Sizing up the market's new risk. This is looking at our biggest corporations and their risk to climate change. Economic impacts, Brent Sanjan will be talking about those. How do we manage a world with threats from climate change, rising sea levels, and rising energy consumptions? And here on campus, we have Jeff Balecki, who will be talking about energy impacts. We have Cinnamon Carlarn talking about policy and law. These are all related. As Jan was saying, the whole system is related. So how are we doing? Here's Keeling's curve starting in 1958. And if you look at this, the rate of CO2 increase in our atmosphere is accelerating. The first IPCC report came out in 1990. Every 5 to 7 years, those reports, these are a global compilation of our best scientists, and the evidence for the human-driven climate change has become stronger and stronger and stronger. And yet you see, in fact, the CO2 curve is accelerating. So how we project this in the future, how do we bring about an actual change on the trajectory that we're in? And this comes down to communicating climate change. And I think we have to do this in a positive framework. If we undertake mitigation, if we undertake adaptation, there are economic opportunities here. There's reduced risk, there's improved health. All of these are extremely important. So how we communicate. And we have Eric Nesbitt and Jacqueline Brickman here at the university who will talk about this communication. So let me draw this to a conclusion because my topic is challenges. And I believe that the greatest challenges in the 21st century are twofold. Learning how to get along with each other on this planet, and that's been with us a long time, and you can argue about how well we're doing that. But the next is learning how to get along with the planet on which we all depend. These two challenges deal with human behavior, and therefore they're very closely related. And we're very fortunate to have Robin Wilson, who will be talking about human behavior. So we're very fortunate to live and work on a campus where we have such a diverse group of scientists that can tackle what is an extremely complex problem. So thank you very much for your attention. I look forward to the discussions. Thank you.